If you enjoyed this podcast, please consider liking, sharing, and subscribing to the channel. Sharing it with your friends and family helps spread knowledge. And when we help others grow, we grow too. Thank you so much for listening. Let's dive into the podcast. Genesis of the paradox. Equal beginnings, unequal fate. Picture the first moment of everything. A flash of creation so brilliant, it birthed space and time itself. In that instant, something went terribly wrong with the universe's plan. The Big Bang was supposed to be fair. Every piece of matter should have had its evil twin, antimatter. These twins hate each other. When they meet, they destroy each other completely. Nothing remains but pure energy, like two ghosts canceling out forever. Scientists drew the math on their boards. Equal amounts of both should have emerged from that cosmic explosion. Then they should have found each other immediately. The result? A universe filled with nothing but light. No stars, no planets, no you or me. But here we sit, made of matter, breathing matter, living on a ball of matter spinning through space. Something saved us from complete destruction. The first clues came from deep space. Telescopes searched the darkness for anti-galaxies, entire collections of antimatter stars that should exist somewhere out there. They found nothing, not a single anti-star shining in reverse. Then came stranger evidence. The cosmic microwave background, ancient light from the universe's baby picture, told a shocking story. It showed a cosmos already dominated by regular matter, just 380,000 years after birth. The battle was over before it barely began. Particle accelerators on Earth tried to recreate those first moments. They smashed atoms together at incredible speeds, making tiny amounts of antimatter. Every experiment confirmed the same disturbing truth. The universe plays favorites, and we are the chosen ones. But why? What cosmic cheat code allowed matter to win this fundamental war? Scientists call it the missing symmetry problem. Somewhere in the quantum laws that govern reality, a secret rule tilts the game. For every billion antimatter particles that died, 1,000,000,001 matter particles survived. That tiny difference, one extra particle per billion, built everything we see. The search for answers became desperate. Hidden chambers in underground laboratories now hunt for antimatter signatures in cosmic rays. Satellites scan for telltale gamma rays that would signal matter-antimatter collisions at the edge of space. Each search comes up empty. Some whisper about influences we cannot detect, forces that guided the early universe toward this lopsided outcome. Others point to physics beyond our current understanding, secret principles that favor matter over its mirror image. This cosmic mystery launched what many call the greatest crisis in modern physics. The math says we should not exist. Yet here we are, asking why. The universe kept a secret about its birth, and that secret may change everything we think we know about reality itself. Unveiling CP violation, cracks in nature's mirror. Physicists believe they had found a perfect mirror in nature. Matter and antimatter should behave exactly the same way, just in reverse. This rule seemed absolute, written into the fabric of reality itself. Then came 1964. James Cronin and Val Fitch peered into the heart of tiny particles called kaons at Brookhaven National Laboratory. What they saw broke every rule in the book. The kaons were acting wrong. It should have decayed one way, following the perfect mirror law. Instead, they chose a different path. Matter and antimatter were not playing by the same rules after all. This discovery sent shockwaves through the scientific world. The mirror was cracked. Nature had a preference, a bias that no one expected. Scientists called this strange behavior CP violation, a fancy name for nature's hidden unfairness. More proof came rolling in over the decades. Experiments at massive facilities confirmed the same shocking truth. At CERN's underground chambers, particles called B mesons showed the same bias. Later, D mesons joined the rebellion against perfect symmetry. Each discovery made the mystery deeper. If these particles behave differently in laboratories on Earth, what did this mean for the entire universe? Scientists began to whisper about a connection to our cosmic puzzle. The weak force, one of nature's 4 basic powers, seemed to be the culprit. This invisible force was secretly tilting the scales, making matter slightly more likely to survive than antimatter. But the violations found in labs were tiny, almost invisible. Here's where things get strange. The amount of CP violations scientists can measure should not be enough to explain why our universe is made of matter. The numbers don't add up. There should be more bias hiding somewhere, operating in shadows beyond our current understanding. Some researchers suspect neutrinos, ghost-like particles that barely interact with anything, might hold extra secrets. Others point to the Higgs boson, or mysterious extra dimensions folded into space itself. These ideas sound like science fiction, but the evidence keeps pointing toward hidden layers of reality. At facilities like LHCb, Bell, and Babar, scientists chase these phantom violations with increasing urgency. Every experiment reveals new questions. Every measurement hints at forces we cannot yet see or understand. The most unsettling possibility haunts the scientific community. What if the standard model, our best theory of particle physics, is missing crucial pieces? What if unknown laws govern the deepest levels of reality? Laws that ensure matter wins over antimatter in ways we cannot yet grasp. These hidden influences might operate on scales so vast or so small that our instruments cannot detect them. They could be shaping the universe's very structure while remaining completely invisible to human observation. The mirror of nature is shattered, and the pieces point towards something extraordinary waiting in the darkness. The Baryon conspiracy, Baryogenesis, and out-of-equilibrium secrets. In the quiet halls of research centers across the globe, scientists huddle over computer screens displaying data that refuses to make sense. They are chasing ghosts from the beginning of time. Something happened in those first moments after the Big Bang. Something that saved our universe from vanishing into nothing. The mystery has a name now: Baryogenesis. It sounds complex, but the idea is simple. In the early universe's chaos, matter somehow cheated death. The rules of physics say matter and antimatter should have destroyed each other completely. Yet here we sit, made of matter that should not exist. 3 conditions must be met for this cosmic trick to work. Andrei Sakharov figured this out decades ago. First, the number of particles cannot stay the same. Second, certain symmetries must break down. Third, everything must happen when the universe is far from balance. These 3 keys might explain why we exist at all. Deep underground in Switzerland, the Large Hadron Collider smashes particles together at incredible speeds. Each collision recreates a tiny piece of the early universe. In 2025, the LHCb experiment found new hints of asymmetry between matter and antimatter. The differences are tiny, almost too small to measure, but they are real. Scientists debate what caused these differences. Some believe unknown particles appeared during phase transitions, when the universe changed from one state to another, like water turning to ice. Others think high-energy events created conditions we cannot imagine today. The truth might involve physics we have never seen. Supersymmetry offers one possible answer. This theory suggests every known particle has a hidden partner. These phantom particles might have tipped the scales toward matter. But after years of searching, no one has found them. The silence is troubling. Research teams work around the clock, checking and rechecking their data. They know they are close to something big. Particle accelerators push the limits of technology, hunting for signs of processes that violate the conservation of baryons. Each experiment costs millions and takes years to complete. The gaps in their knowledge grow more obvious with each failed attempt. Theoretical models predict certain outcomes, but nature refuses to cooperate. Some researchers wonder if they are missing a fundamental piece of the puzzle. Others suspect that quantum effects or cosmic events they cannot detect secretly shaped our reality. The human drama plays out in conference rooms and scientific journals. Rival theories compete for attention and funding. Young researchers bet their careers on ideas that might never prove correct. Veterans share stories of decades spent pursuing leads that vanished like morning mist. Something extraordinary happened 13 billion years ago. The evidence surrounds us in every atom of our bodies, yet the mechanism remains hidden, protected by the vast distances of space and time. The conspiracy of physical law continues to guard its secrets. Shadows in experimental evidence, collider discoveries, and missing pieces. Deep beneath Switzerland, machines hum with power beyond imagination. Scientists at CERN fire particles around a 17-mile ring at nearly the speed of light. When these particles crash together, they recreate moments from the birth of our universe. Yet what they find troubles them deeply. The data screens glow with numbers that should not exist. Every collision should make equal amounts of matter and antimatter. But the reality is different. Matter wins again and again in ways that current theories cannot explain. Dr. Sarah Chen stares at her computer screen at 3 in the morning. The LHCb detector has been collecting data for months. The results show something impossible. Certain particles called baryons are behaving strangely. They decay in patterns that violate everything physics textbooks teach. Across the Atlantic, researchers at Fermilab see similar oddities. Their experiments with rare antimatter nuclei produce results that make senior physicists question decades of work. Antihydrogen atoms act differently than they should. The measurements do not match the predictions. Something is missing from our understanding. The experiments at Brookhaven add another layer of confusion. Particles appear and vanish in ways that suggest hidden forces at work. CP violation. The subtle difference between matter and antimatter behavior shows up in unexpected places. Teams compare their findings across continents. The data tells conflicting stories. What CERN discovers does not always match what Fermilab sees. Some results point toward new particles that theory says cannot exist. Others suggest that fundamental constants might not be constant at all. The missing antimatter becomes more mysterious with each experiment. Scientists expected to find clues that would solve the puzzle. Instead, they discover new questions that challenge everything they thought they knew about reality. Late-night discussions in laboratory cafeterias grow heated. Veteran physicists argue with younger researchers about what the data means. Some suspect experimental errors. Others believe they are seeing evidence of physics beyond current models. The numbers keep coming in. Each measurement adds weight to a growing suspicion that something profound eludes detection. The universe holds secrets that particle accelerators cannot fully reveal. Hidden mechanisms seem to favor matter over antimatter through processes that remain invisible to our most sophisticated instruments. These findings reshape scientific conferences. Theoretical physicists scramble to create new models that can explain the anomalies. Yet every proposed solution creates new problems elsewhere in the equations. The search continues in underground tunnels and control rooms filled with blinking lights. Each collision brings hope for answers and fear of deeper mysteries. The universe appears to guard its secrets jealously, revealing just enough to keep scientists guessing. What force tipped the cosmic balance toward matter? The experiments suggest the answer lies just beyond our current reach. The unresolved question: are answers forever out of reach? Scientists have pushed their instruments to the very edge of what is possible. Yet the answer remains hidden. Every experiment brings new questions instead of clear solutions. The most powerful machines on Earth have searched for clues, but the mystery only grows deeper. Three competing theories fight for acceptance. Each one explains some pieces of the puzzle, but none can solve it completely. Scientists argue in meetings and write papers that challenge each other's work. The debates grow heated because so much depends on finding the truth. Massive gaps exist in our understanding. We can see what happened, but we cannot explain why. Experiments that should reveal secrets instead show us how little we truly know. The scale of the problem feels overwhelming. We are trying to understand events that happened in the first tiny fraction of a second after the universe began. Some researchers believe new particles wait to be discovered. These hidden pieces might hold the key to everything. Others think we need entirely new laws of physics. The rules we know today might not be enough. Perhaps reality operates in ways we have never imagined. Dark matter complicates everything. This invisible substance makes up most of the universe. Yet we cannot touch it or see it directly. Could it be connected to why matter won? Some scientists think so. Others point to primordial black holes as potential suspects. These ancient giants might have played a role in the cosmic drama. The most unsettling possibility haunts every discussion. What if nature has placed this secret permanently beyond our reach? What if some truths cannot be found, no matter how hard we try? This thought troubles scientists who have dedicated their lives to finding answers. The stakes could not be higher. Understanding this mystery might reveal how the universe really works. It could change everything we think we know about reality. Yet decades of searching have produced more questions than answers. Rival research teams work around the clock. They build bigger machines and design cleverer experiments. Each group believes they are close to a breakthrough, but the breakthrough never comes. The mystery adapts and evolves, staying one step ahead of human knowledge. The philosophical implications run deep. If we cannot solve this puzzle, what does that say about the limits of science? Are there boundaries to human understanding that we can never cross? The question challenges our deepest beliefs about discovery and truth. Perhaps this cosmic conspiracy will never be solved. Perhaps the universe guards its secrets more carefully than we imagined. The story continues with no ending in sight. And maybe that is exactly how it was meant to be.